National Workshop, Remote Access to Lab on Screen. For this session, we have two speakers with us, and yes, both of them are from our institute, that is from Jorhat Kendriya Mahavidyalaya. Bhaskar Kolita and Trisha Rajguru. And Bhaskar Kolita's topic is similarity search of sequence through BLAST, and Trisha's topic is analysis of primary structure of protein. And yes, both of them will demonstrate these practicals through virtual lab. And I hope this session will be very interactive, interesting, and the participants will be able to learn few things on bioinformatics. I request Dimpli Bora, Assistant Professor, Botany Department of Jorhat Kendriya Mahavidyalaya, to introduce our first speaker, that is Trisha Rajguru. Dimpli, can you hear me?
Yes, ma'am. Yes, ma'am. Thank you, ma'am. Good morning, everyone. Respected Principal Sir, Convener Ilipukan ma'am, Coordinator Pinaki Hajurika ma'am, respected faculty members, and all the participants present here. First of all, I would like to welcome all of you for today's practice. Today, we have Mrs. Trisha Rajguru ma'am, Assistant Professor of Department of Zoology, Jorhat Kendriya Mahavidyalaya, with us. She is awarded with prestigious DST Women Scientist A Award in 2017. Her research area is MD simulation of proteins, drug discovery for malaria and bioinformatics. She has a couple of published research papers in peer-reviewed journals also. So now I would like to request Trisha ma'am to proceed with her topic, that is primary structure analysis of protein using virtual lab. Thank you, and over to you, ma'am.
Thank you, Dimpli, for the introduction. I think I'm good to everyone.
Yes, very much.
Okay. So, good morning to one and all present in the meeting. So, today I am here to demonstrate a practical, that is primary structure analysis of protein in virtual lab. So, let's begin. Now, the aim of the experiment is primary structure analysis of a protein using param tool in virtual lab. So at first, let us go to do the practical. So in Google search, I will place virtual lab. So I will give a search in the virtual lab. So this is the virtual lab. So we have entered into the home page of the virtual lab. So this is the home page of the virtual lab. So and there are some broad areas of virtual lab. Broad areas of virtual lab. That is, we have different broad areas. So we are going to click to the area that is biotechnology and biomedical engineering. So we are going to click to this biotechnology and biomedical engineering. Just have a click on it. So on clicking that particular area, so we will then enter into a page that where you will have a list of different labs available from different sources that is ready to be used. So today we are going to this Bioinformatics Virtual Lab 3 from Amrita Vishwa Vidyapitham. So on clicking to that particular lab, we will enter into the Bioinformatics Lab 3. So on entering the lab, Bioinformatics Virtual Lab 3, there again you will find list of experiments that can be done with the inside this lab. So today we are going to do, as already I have said, the name of our experiment or the aim of our experiment is primary structure analysis of protein using param. So we will just have a click on it. So we'll just have a click on it. So there are some, so this is the page entering the primary structure analysis of a protein using param. So this is the page we have entered into protein using param. So name of the experiment is given at the very beginning. Primary structure analysis of a protein using param. Then there is a different sections are available. Like theory is available. Procedure is available, self-evaluation is available, simulator is available, assignments are available. So these are different sections available. So theory is the theory of this particular experiment. Theory is available. Then we can go to the procedure also. Procedure is also given here. Then after going through the theory, after going through the theory, if you want some more knowledge about it, want to gain some more knowledge about it, you can just go to references where you will find some journals, some research papers available related to this experiment, and some bibliographies are also available. Then after going through the theory, after going through the references, we can then go to the procedure. Then we can simulate the experiment. We can simulate the experiment. We can do the experiment. Then we can also self-evaluate ourselves, how much we have understood. There is also a section of assignment given. So after completing the complete reading the theory, procedures, then simulator, you can do certain assignment which has been given in here. You can practice session, that is, there are some practice given, so you can just go through it. Then apart from that, there is another section available, that is feedback. You can also give a feedback to this particular lab that we have entered, Biinformative Lab 3 from Amrita Vishwavidyapitham. We can just give a rate to this lab. So these are different, and this is common for all the practicals, all the experiments in the virtual lab. So this section is common for all. So now let's go to our practical that I am going to do today. So that is primary structure analysis of a protein using param. So objective of this experiment is to compute the various physical and chemical parameters of a protein, to perform primary structure analysis of a protein, to introduce a protein analyzing software that is available through the SPC server. SPC stands for EX stands for expert, P stands for protein analyzing system. So this is the server where you will find different tools available for analysis of protein. Although it is given here as software, but it is not actually software, it is a webware, because we are going to access that tool through our website. And you need not have to install it in your computer. So now let's go to the theory of this experiment. As we are all from the field of biology, so we all know that proteins are one of the fundamental units of all living organisms. They perform different functions in our body, starting from DNA replication, catalysis of metabolic reactions, transportation of molecules from one location to another, etc. Now, what are these proteins made up of? Proteins are made up of amino acids. So, amino acids are the building blocks of protein. And these amino acids are in turn made up of amine group and a carboxyl group. Apart from the amine group and a carboxyl group, it has also a R group that is specific for each amino acids. There are about 20 amino acids found in the human body. which usually varies only in the R group. And in protein, these amino acids are connected to each other or linked to each other through a bond that is called as a peptide bond. So a peptide bond is formed when carboxyl group of one amino acid is linked up to amino group of another amino acid through a covalent bond. So this is what is the primary structure. Although protein exists or protein's structure are classified into primary, secondary, tertiary and quaternary structures, but focusing on our experiment, as the name of our experiment implies that we are going to analyze the primary structure of a protein. So we will focus on the primary structure, that is your this amino acid linking up to one another through peptide bond. That is the primary structure. We are going to analyze this structure of a given protein using param tool. And now from where we will get this param tool? This param tool is available in SPC server. Yes? Okay. This server is, this tool is available in the SPC server, and you can access that this particular tool through the link which has been provided here. And this param tool is going to calculate the physiochemical parameters of a given protein. We did not have to do anything. It is going to calculate everything for us. It is going to give us a result. Now, what we have to do is that the only input that has to be provided to the tool is a protein sequence. We just have to insert the protein sequence into the tool, and it is going to compute all the required parameters for us. So the various parameters that it is going to compute are molecular weight, amino acid composition, extinction coefficient, estimated half-life, theoretical PI, grand average of hydropathicity, aliphatic index, and instability index. Now, there is also a description given here how this calculate or compute all these parameters. So let us go through it in short. That is molecular weight, how it is going to calculate the molecular weight. In param, the molecular weight of a protein is calculated by addition of average isotopic mass of amino acids in the given protein and the average isotopic mass of one water molecule. Extinction coefficient, the extinction coefficient illustrates how much light a protein absorbs a certain wavelength. Then theoretical PI is the isoelectric point. So theoretical PI is calculated using pKa value of amino acid. The pKa value of amino acid depend on its side chain. It has an important role in determining or defining the pH dependent characteristics of a protein. Half-life, the half-life is a prediction of the time it takes for the half of the amount of protein in a cell to get disappeared after it is being synthesized. Then grand average hydropathicity or gravity value of a protein or a peptide is calculated by adding the amino acid and dividing by the number of residues in the sequence or length of the sequence. Increasing positive score indicates a greater hydrophobicity. Then next is the aliphatic index. The aliphatic index of a protein is described as the relative volume occupied by amino acids such as alanine, valine, etc. Then instability index. Instability index provides an estimate of the stability of your protein in a test tube. A protein whose instability index is smaller than 40 is predicted to be stable, and a value which is above 40, the protein is considered to be unstable. So these are the theory that is available for this particular experiment. Now let us go to do the practical. That is, we will switch on to simulator now. Now, on clicking on to simulator, we will see a page where we have to log in. Now, if you are a new user, you have to register to it. And and registration is very easy and is free of cost. That is a very good news for all the students present here. So, and since I have already registered, I will enter into it through my Google account. So I will enter into it through my Google account. So on entering giving or login to it, the lab, we will be able to enter into the simulator. So in the simulator page, you will find the simulation steps. That is, you are going to do the practical. Now in step one, you will see what to do here. That is, as I have already said, that the only input that has to be provided in the tool is the param tool is the protein sequence. Now, how you are going to sequence for a given protein? That can be done in two ways. Number A is given here, number B is given here. So A option is just input the accession number or the ID of the protein. And B option is just input the FASTA format. So at first, let us go with the option A. So we will just input the ID or the accession number of a protein. Now how to get that? We will get that through this URL provided. So just we have to copy this URL and paste it in a new tab. Paste it in a new tab. Okay? Is it available? Is it? I think my screen is still on.
Signing screen is coming on.
Okay. Okay. So after logging into the page, after logging into the simulator, there will be two options available how to do the experiment. That is, we have to retrieve the protein sequence. So to retrieve the protein sequence, first option we are going with the option A. That is, we will just copy the accession number or the ID of a protein. So on entering, on clicking the URL that has been provided in the simulation step, so we'll just click onto it and open into a new page. So on clicking on it, we will enter into this database.
Excuse me, I think you are on the same page, login, sign in page. I don't know. On my screen it is.
Yes.
You are muted. Isha, you are muted.
Okay. Okay. Again muted, Tisha. Now we will go to the Uniport. We'll go into the Uniport. So after logging in into the simulator, then we have clicked the URL that has been provided in the simulator step. Then we have entered into the Uniport database. So here we have to pay just in the space provided. We have to enter the protein name, whichever protein our desired protein. We have to write the name. Then we have to just click the search button. So say for example, I have typed here keratin as the name of the protein, and then we can go into this page. So on clicking to it, we have entered into the page of Uniport, and on clicking the search button, we will then have to just click the entry name. We have to just click the entry name. We have to copy the entry name, and we have to paste it in the new in the param tool. Yes, we have to. I'm waiting for the page to get refreshed. So then we have to copy the URL. After clicking just wait a second.
Trisha, you are in the same page, Uniport page.
Yes, I'm waiting there itself for the page.
No, you are in the Uniport page.
I'm there in the Uniport page itself.
Okay, then it's okay.
So the name of the protein has not come in the box, so I'm waiting there. Page to change. So after clicking and writing the name of our protein on the Uniport, so we will just have to hit the search button. So on clicking the search button, you will enter into a page where you will find several proteins with the entry name. So several proteins are available. So since we do not have any specification or just it is a demonstration, so I will click any of the protein that is keratin that I have given. So I just copy the entry name of the protein keratin. So we will enter into the page. Okay, we will just copy this and yes, here it comes. The entry name is given here. So we will just copy the first entry name of the protein keratin. So Q14533. So we'll just copy, go to the procedure of the experiment in the virtual lab. So in the procedure, we have to see what is given here. In the procedure, it is given here. What to do in the procedure is given that we have to just put that entry name of the protein, because we are this time we are going with the accession number. We are going with the accession number or the ID of the protein, because protein sequence can be input in two ways. Either it may be the accession number or the ID of the protein, or it may be the FASTA sequence. So we are now going with the accession number. So we have copied the accession number of the protein from the Uniport database, and now we have to click to the according to the procedure, we have to just paste it in the param tool. Now to paste it in the param tool, we have to just copy the URL which has been provided in the procedure. So to just copy it and then paste it in a new tab, which will lead us to the SPC server. This SPC server, as I have already told that this is a server that contains several tools for protein analysis. Now, our required tool is param, so we have to give a search on it. So this on having search to it, we will then get the required result in a short time. Otherwise, we can also just scroll and search for our protein tool, but that will require a much longer time. Since it is a server, it contains several tools for analysis of protein. So we will then give a search for it and then give the search button. So on it, we will go into the, here it comes the search option, that is, we have found the param tool. So on clicking the param tool, now we'll just click to the param tool to enter into the param page. So on entering the param page, there again, a little bit description is given about the param. What it is going to do. It is a parameter. It is going to compute the various physiochemical parameters of the protein, and it is also we have to browse to the resource website. We have to go to the website. So this is actually a web where we are going to go to this param tool, access this param tool by to the website. So we have to go to the. So on entering the website page, now. Here it is given here that please note that you may only fill up one of the following fields at a time. That means you have to either fill up the entry name or the ID of the protein, or you have to fill up the FASTA sequence. So as we are going with the option A this time, so we will just the protein here, protein ID that we have copied from the Uniport, we'll just paste it here, and then we have to, we will ask the param tool to compute parameters. Then on clicking the compute parameters, then it is going to ask us whether we require the entire protein to be entire protein to be computed, or we require the parameters for the entire protein to be computed, or we require only the only certain segment of it. Segments are available that we require from this amino acid to this amino acid. But since here we do not have any specification, by default it is going to compute the parameters for the entire protein. So we will, on clicking submit, it will just compute the parameters for the entire protein. And I'm going to now click the submit button. On clicking the submit button, you will get the result. This is the result sheet of our protein that we have provided. That is, number of amino acids you got as 505 amino acid, molecular weight this much, theoretical pi this much, atomic composition also it has given us. So this is the atomic composition. Then total number of negatively charged residues are also given, positively charged residues are also given. Then atomic composition also it has given us, it is carbon, how much, hydrogen, nitrogen. So these are the different composition. Formula is also it has given us, and total number of atoms also it has given us, extinction coefficient, estimated half-life, instability index, aliphatic index, and grand average of hydrophobicity, etc. It has given. So these are our parameters that we have already gone through in the theory part. So it has computed all for us. So this is the simple experiment where we will get we got the result sheet. So this is a result sheet for us. Now I want to repeat the experiment with the second option. As I have said that in the simulator step there were two options were there. In the param, we are using for doing the experiment, we are using the tool param. Now this param tool requires a protein. Only the input that we have to provide in the param tool is a protein sequence. Now protein sequence can be input in two ways. Either it may be in the ID of the protein, or it may be in the FASTA sequence. So now, first, initially we went with the ID of the protein, ID of the protein, or the accessory number of the protein. Now this time, let us try with the option B, that is input of the FASTA sequence. Now, how to input the FASTA sequence? We will go to this URL which has been provided here in the simulator step. We'll just copy it and paste it in a new tab. So just we have to copy it and paste it in the new tab. On clicking on just pasting in a new tab, we will find we will then go into that particular website. So this is the website of NCBI. After just pasting here, we have to just click the search button. So NCBI is a database where you will find the different proteins information. So here we have to just select. Again, we have to wait for a couple of seconds for the page to be loaded. So in between, let me just revise what we have done. So this, we are using this param tool. Already we have finished the experiment doing by one option, that is by putting the accession number. So accession number, we simply have to put the accession number of the protein, and then we have to just put it in the param tool, and then okay, we will put it in the param tool, and then it is going to complete for us. So here it comes, the page that is after clicking on that URL, you have entered into the NCBI page. You have to select protein here, and then you have to give any protein name, your desired protein name, which you want to compute. So you have to write the name of the protein. So for example, I'll type here, falciparum. So falciparum is a protein of malaria parasite. So here comes the page with chain B, chain A, chain D. Different specifications are there. So again, I say this is a demonstration. Just I don't have any specification of A, B. So I'll just click on the first, that is chain B, cysteine protease falciparum. We get the FASTA sequence here. Option is given here, FASTA. We just have a click on it. And on clicking the FASTA, you will get the FASTA sequence for the protein, that the name that you have provided. You just copy the FASTA sequence. You have to copy it, and then you have to paste it in the param tool. You have to paste it in the param tool, and then is remaining procedure is same as the earlier. You have to enter into the resource website. Then in the here you have to paste it in the space provided for the FASTA sequence. Now we would not have to put anything. You have to keep the box blank for the accession number or the ID of the protein, since we are now pasting only the FASTA sequence. Just we have to copy the FASTA sequence, and we have to paste it in the space that has been provided in the param tool for the space that has been. Then you have to ask the tool to compute parameters for this particular protein. On clicking the submit button, you will get the result sheet. So this is the result sheet where you will get the number of amino acid for the second protein, molecular weight this much, then theoretical PI this much, then amino acid composition, that alanine contribute how much, how many alanines are there, 12 alanines are there, it contribute about 5%, arginine is 7, it contribute about 2.9%, and so on. So even you get how many negatively charged residues are there, how many positively charged residues are there, what is the atomic composition, etc. So these are different results that we have obtained for the second protein. So this was the first protein result sheet, and this was the second protein. We are doing the same procedure, but only thing is that since I have told you this is a very simple experiment of just you have to use the tool, and you have to paste the required protein sequence. So protein sequence can be pasted in two ways. One is accession number, and another is the FASTA sequence. So first we have done with the accession number. We have copied the accession number from the database and pasted in the param tool. And then second one, we have just copied the FASTA sequence of the desired protein, and then we pasted in the param. So that simple step will give us the result. So it is very simple, and this is what is a virtual lab. So I think, and this virtual lab is quite user friendly. The only thing is that you have to have a good source of internet, and otherwise it is very user friendly. And I think I hope that I could familiarize you all with the virtual lab, how to do the practicals in virtual lab. The basic that I have said in the basic thing that the first you have the aim of the experiment. This page, the entire page is common for all the experiments. So first you will get the primary, the name of the experiment that is common for all the experiments. Then you will get theory, procedure, self-evaluation, simulator, assignments. After doing so, now we can since you have underwent through the simulator procedure steps, you can now go for assignment and do it yourself. Then you can also have some more knowledge about it through references. And you can also rate the lab accordingly. So this is a very simple experiment that I have demonstrated today. I hope I could familiarize you all with the use of virtual lab. So with that note, I conclude. Thank you very much for your kind attention and patience, because internet is always on a thing mode. So we have to cope up with the internet. Thank you. And of course, I would like to thank Principal Sir and all the members, organizing members, convener, coordinator, for giving me the opportunity to deliver this demonstration to our students or other interested people. Thank you very much.
Thank you, ma'am, for your wonderful session. You made it very easy to understand us, the topic, very clearly, actually. I hope it is helpful to all the participants present here. Thank you, ma'am, once again. Okay, now we have Ms. Bhaskara Kalita sir, Assistant Professor of Department of Botany, Jorhat Kendriya Mahavidyalaya with us. His research area includes the bioinformatics as well as drug designing and development. He has published several research papers in international journals also. So now I would like to request him to proceed with his topic, that is similarity search in sequence trophlast. Thank you, and over to you, sir.
Thank you, Dimply.
Yes.
Good morning, everyone. Respected Principal Sir, respected Convener Ilipukan Ma'am, Coordinator Pinaki Hazarika Ma'am, respected faculty members, dear students, and all the participants. Today in this practice section of the workshop Lab on Screen, we are going to practice a blast experiment, which was already shown by my teacher from yesterday, resource person Dr. Pankaj Sitya sir. Without no time, we are going to start. You can also do at the same time using your mobiles or laptop. Very simple experiment, as previous last session already done. You can perform at the same time, such that you can get, if you get any problem, you can ask me. For blast experiment, you can go through Biinformative Lab 2. There are 3 virtual lab of Biinformatics by Amrita Vidyapitham. Last session, Dr. Pankaj Sitya shows you by directly in from Google. I will start today's form by I will show you through a virtual lab. That is, there are 3 virtual labs I already did. Virtual lab 2, 1, 2, and 3. We can share. Just for a minute. For this, first we directly can type virtual lab 2, bioinformatics virtual lab 2. Just bioinformatics virtual lab 2. Informatics. Here we have to click on the first step where you can Biinformative Lab 2. Just click on here. Here a different list of experiments are here. We are going to pair sequence alignment using BLAST. For this, we have just click on this pairwise sequence alignment using BLAST. Just click on here. The advantage of this virtual is that just steps are there already written here. So you can go through the steps and perform step by step. No required to, if you forget anything, no need to worry. You just go to the steps and you can follow the steps one by one. Here is the theory is given here. This theory is also given by our research person, Dr. Pankaj sir. The aim of this experiment is to find homology sequence. Homology sequence means you understand maybe. Most of the attendants, the participant can know that what are the homology sequence. It is the similar sequence of the given sequence of a particular sequence. This helps if what is the aim of this to find that similarity sequence. It's already told by Pankaj sir. It's help to find the root or origin of the organism or organism. It determines the phylogenetic relationship between different sequences. This is the aim of the experiment of BLAST. For this, to perform this experiment, we have to click on here as already steps are done by Sam. Another practical. Just we have to go to click on stimulator part. Just click on stimulator. Here we have to sign up with a free account. For a free account, just click on free signing up. Just you have to click on the email ID, confirm your email ID, password, confirm password, first name, last name, age group. At this personal details you have to fill up, and then you can click on register. Then it will be registered freely. Do I have an account on this virtual lab? I just go to click on login option. Here I have already signed in. I have to click. If you are new user, then you have to click on email ID or password also. I have already in this virtual lab, so I have to click on only login option. Just click on login option. After login, we have I have already said that different steps to perform the BLAST experiment or any other experiment in virtual lab. The steps are given. Just we have to follow the steps to perform this experiment. Here, step 1 is given. Step 6 steps are there to perform this experiment. Okay. To first steps, we have to go to the home page of NCBI. For this, we have to click on the URL given here. Step 1, URL is given here. Just click on the URL. This is the home page of NCBI. This NCBI, Pankaj already said yesterday. It is a clear National Center for Biotechnology Information. It is nothing but a database. Database means collection of data and organized in a systematic way. This database. That was just said by our research person, Dr. Pankaj sir. Here we can observe a tab. Are you observing all databases? Last session, Dr. Pankaj have shown all databases. Have you seen, notice all databases option?
Yes, sir.
Here, here see, if we click on all the databases, then define the task stored in the NCBI and the NCBI are you will see the define the task so stored in the NCBI. Let's see that is you can find both a gene, genome, protein, nucleotide. Defines the tasks are available here. Okay, for blast experiment, we need protein sequence or nucleotide sequence. For this reason, we are going to click on protein sequence. Just go to all database and click on protein sequence. Here is the protein sequence. Click on the protein sequence. Now we have to retract a protein sequence. Particularly, student cannot remind the names of proteins. So we can go to, we can search for an organism. Such that the defined proteins are present in this or in that organism. You can see and you can select from them. For this reason, we are going to select a current virus which created the recent pandemic, that is COVID-19. We are going to type COVID-19 on this search option. After typing the organism name, you can also type women, E. coli, anything that any organism you can type here. The sequences are protein sequences are listed on the pin. We click on COVID-19, then click on search option. See, this is a list of protein sequence of COVID-19. In the first page, we see 20 sequence. If we click on next page, another 20 sequence will be visible. Equal to 40. And if we click on next page, another 20 will be visible, and so on. And there are almost more than 47 lakhs of proteins of COVID-19 stored in NCBI. Under NCBI, more than 47 lakh proteins of COVID-19 are stored. For blast experiment, we have to select one of the protein. We can directly take the sequence only. There defines two formats of sequence, that is graphics and FASTA. The graphics sequence give all the details of the sequence, the amino acid, etc. And FASTA sequence, if it is format of sequence where sequence only the sequence can be retrieved from the FASTA format. Here one thing is more. We can also observe how many amino acids are there in a protein. Number 21, you can notice there are 275 amino acids in this protein. Number 2, we can notice there are 1,273 amino acids. Number 23, 4,405 amino acids are there. And so, and this amino acid, how many amino acids are there are also given here. We can go through the whole sequence, whole protein sequence details, but we don't need, no need to go through the whole sequence. We just need the FASTA format so that we can retrieve the only sequence for the blast experiment. For that, here you can click on FASTA directly here. Graphic FASTA, identical protein, gene paper, like this is the format of a sequence. We need the FASTA format. It is a format of a sequence where only the sequence are available. So we are clicking on FASTA format. After click on first the format, we will observe the sequence here. We have to copy the sequence for a blast experiment. If I required for other further analysis, we can paste in Notepad or WordPad also. But for the time, we don't need to copy it to Word or Notepad file. Just copy it and go to the virtual lab tool. Here, see, number 1 step is done, number 2 is done, that is, go to the NCBI and retype a sequence. Number 3 part is done as to retype the sequence as a FASTA format. Number 4 is to copy the sequence from nucleotide. Number 5 is to perform blast. So the different steps to perform these experiments are given here. You just follow this step. So step number 5 is the first. You have to go to the blast website. For your link is given already here. Or you have to just click on this link URL. Here different programs of blast here. Already Pankaj sir said the different programs about there. We generally use nucleotide blast and protein blast. Nucleotide, if we select the nucleotide sequence, then we have to select on nucleotide blast. If we have select on protein sequence, then we have to click on protein blast. As first we click on protein blast, as we selected the select the protein sequence of COVID-19. So we have just click on protein blast. Here is the window of blast, the home place. Blast, what is blast? Last session, Pankaj already described about blast. What is blast? Anyone? So blast is a tool, online tool. This full form is basic local alignment search tool. So defines algorithm behind there. So no need to go for behind the algorithm. We have a window here. We have to paste the sequence here on the window that we have copied from NCBI. Just paste on here and click on blast blast tab. In the status, we are saying that it is searching. It will take 1 minute, maximum 1 minute time. Then the result will be hopping here. Still searching, and finally result comes out. And this is the listed of homology sequence of a given sequence of the COVID-19 sequence that we have provided in the class. This is the listed homology sequence. Here we have to see in the percentage of identity and E value. We have seen the percentage of identity. First sequence is 100%. Second one is 64%. Third one is 99.64%. Fourth one is 99.6%. And so on. These are the identity. We have also noticed the E value. E value is the expected value, as Pankaj last class said. Expected value means it is the statistical value. That is a probability. Probability. I have studied about the probability. The first identity is 100%. The probability of getting 100% in next experiment, next time or next after some time or after some days, it's given 0. That is, according to Pankaj, this value should be 0 to 1, and it shows 0. That means it is a very good result. This is a result analysis topic. We can also try with this one protein sequence. We can also try with nucleotide sequence, the same method. For that, we have to go there and see the home place again. Just click on, we have to click on nucleotide. Here we can change the organism. We will try with another pathogenic fungus. Recent trying is more in discussion, that is black fungus. Just type on black fungus and click on search option and see these are the list of nucleotide of black fungus. Nucleotide are stored in NCBI 15,000. So here's the length of nucleotide. Number 1 is 577 amino nucleotide. These are the very small nucleotide or protein. We just go for a small size or select a small organism such that the amino acid or nucleotide sequence are small. If the amino acid or nucleotide sequence is long, then the blast experiment will take more times. So we are going to just a small sequence. So I select COVID-19 or black fungus, a small organism. If we click on monkey here, we can, if we click on human here, it is billions of bacteria will be there in the sequence. So we are going with a small sequence. So we go for this small organism. And now we have to select any of the sequence. First one, we will start with. Second one, we have to click on that FASTA format. Click on FASTA format. This one's the FASTA sequence. We have to copy the sequence from the greater than sign. Copy it. And again go to Partial Lab. And click on the plus link. And this time we will select nucleotide sequence. Then for nucleotide sequence, we have to click on nucleotide blast. Then we have to paste here as earlier. And click on blast. And the result again. Then number 1 sequence shows 100% immunity with E value. It's e to the power minus 23. So it is not a good E value. And it's this one. So this is the blast experiment. For it is also included in UG syllabus also for both Google and University also. So hope this experiment will help to the students to perform it and to perform by himself or herself. If time permit, I will show another one that is toxicity prediction. If time is not over, then I can conclude it here. Ma'am?
Yes, Bhaskar. You can take 10 or 15 minutes more.
Okay, ma'am. Now I will go to show you toxicity prediction of a compound, okay, any compound, which is very important for any research field, for such, especially for drug designing, drug property calculation. So I'll just go to the application. It will take within 5 minutes. For this, we have to go to Botany. Here we can type free adenine. And the first option is there. This is the application of online virtual. It is the virtual that it can be said as a virtual that there different tests can be done here. Here's the home page of the Academy. There are different property can be calculated of a compound. This dark light property is how much property how is the probability of a compound to become a drug. ADB property, that is absorption, distribution, metabolism, erection, erection for prediction. And next option is toxicity prediction. The toxicity prediction of a compound. We are going to study the toxicity prediction just. For this, we have to click on the toxicity prediction tab. Just 1 minute.
Bhaskar, are you there?
Yes, ma'am, I'm here. Website is not opening.
Oh, yeah, I think so. So I think Ili can proceed. Your network is not working.
My network is working. The website is not working here. If Element can proceed, I conclude it here only.
Okay.
So over to Dimply. Over to Dimply. Dimply, say
Yes,
few
ma'am.
words to Bhaskar. Few words to Bhaskar.
Thank you, sir, for your wonderful session. It was really an informative one. I hope all the participants are benefited from this session today. Now, with this, we have reached at the end of the session. So I would like to request Ili ma'am to wind up the program. Thank you, ma'am.
Thank you. Thank you, Bhaskar Kolita and Trisa Rajguru. Hope our participants, especially the students, have learned a lot from your demonstration. And for the participants, as you have come to know that our next session will be on chemistry, do join with us. We will meet at 2 p.m. Thank you. With this, I